Hey guys, today we are going to be factoring the difference of squares. You're going to want to get some paper out so that you can write down these notes. So there is, I guess you can say, a formula for factoring the difference of squares. And it is a squared minus b squared equals a plus b times a minus b. Now, don't let the a's and b's confuse you. Once I put some numbers in it, this will make a lot more sense. But if you go ahead and write down the formula, and I do want to point out some things. One, the title, Factoring Difference of Squares, is very important because when you're doing this, you need to make sure you have a difference, which means subtraction. Subtraction is difference of squares. These have to be perfect squares. So a squared is a perfect square, b squared is a perfect square. This only works if you have a difference and perfect squares. If you don't have that, this is not going to work. So we will start with a couple of examples. So let's say I had x squared minus 25, and I wanted to factor that. So first I want to check, do I have a difference? Yes. Are both of these perfect squares? I would say x squared is a perfect square, and 25 is a perfect square because it's 5 times 5. So I want to break that up into two factors. Now, something that will always happen, notice these factors are going to be exactly the same. The difference is one gets a plus and one gets a minus. So I can go ahead and put a plus and a minus. Now, where these two factors come from? A is the square root of a squared. So a times a made a squared. So here for x squared, x times x makes x squared. And here, b times b made b squared. For 25, 5 times 5 is going to make 25. So notice your factors are always the same. One gets a plus, one gets a minus. All right, do another one. Let's do 9x squared minus 36. And guys, if you're not familiar with your perfect squares, I definitely recommend going through them, like literally list 1 squared, 2 squared, 3 squared, 4 squared. I would go all the way to 15 squared just because that's what you could be expected to see. And so if you can learn to recognize all of your perfect squares, then this will make it a lot easier for you. So same thing, setting this up, I have two factors. I know one gets a plus and one gets a minus. So I just need to figure out what makes 9x squared. Well, 9 is a perfect square, and it's 3 times 3. X squared is a perfect squared because it's x times x. And 36 is a perfect square because it is 6 times 6. And this is done. So these are really easy once you realize how to break up your perfect squares. We'll do one more and then we're done. Sometimes you get problems that have multiple variables or have a big exponent, so I just want to show you what that would look like. So let's say I had 16x to the 4th minus, we'll do 81 y to the 6. There we go. So in case you end up with a big one. Don't see this much, but just in case. So nothing changes. I still have a plus and I still have a minus. And just take it piece by piece. Don't get overwhelmed by all these variables and all these numbers. Take it literally piece by piece. So we'll start with 16. What times what makes 16? That would be 4 times 4. What's going to make x to the 4th? Be careful here. If there's 4 x's, that would be x squared times x squared. If I have two sets of x squared, that makes x to the 4th. So x squared times x squared. First one's done. What makes 81? That's going to be 9 times 9. And what makes y to the 6? If there's 6 y's, That means half of them were with one and half are with the other. So I have y cubed times y cubed. So don't be intimidated by these big ones. You just take it one piece at a time. Notice your factors are always the exact same. One gets a plus, one gets a minus. So that is all for factoring difference of squares.